Hi there and welcome to video 4, which is a video on the exam questions on the AQA Unit 3 higher paper that come up in regards to trapezia or a trapezium. You should have watched video 3 and have yourself a revision card on what a trapezium is and how to find the area. In theory now you should be able to answer these higher paper questions that came up on a trapezium. So I'll show each question, I'll stop talking for 10 seconds, but you pause the video, have a go, and then see if you got the right answer that I show you. So here we go, pause the video, have a go at this first question. Okay, you should have had a go at this question by now. It told you that the diagram showed an isosceles trapezium. The key thing that should have been on your revision card about an isosceles trapezium is that this angle and this angle are the same, and this angle and this angle here are the same. So you should have been able to write in that that was 75 and this angle here was x. You don't know. It said work out the value of x. Now, you should know that angles in a quadrilateral in a four-sided shape add up to 360. Okay, so in order to be able to work out, in order to be able to work out these, how many x's do we have? We have 2 x's, and 75 at 75 is 150. So 2x plus 150 must add up to 360 degrees. Then to solve for x, you do 360 subtract 150. And you get 210, and then you half it. So let's do that instead. 2x would be 360, take away 150, which is 210. So 1x would have been half this, which would have been 105. So 105 degrees would have been x. Have a sense check. Does it look right? Well, yes, it does look right. Another way of doing it, and maybe a nice and easier way of doing it, you know that in a trapezium, these two sides are parallel. And you know a rule with parallel sides, if you've got parallel sides such as this and a line crossing them, you know that always this angle and this angle must add up to 180 degrees. This is called supplementary angles. So if that one's 75, that has to be 105 to add up to 180. So that's probably a slightly easier way of doing it. Okay, work out the area of the trapezium. Well, you turn to your formula booklet and it tells you that the area is a half a plus b times h, but you remember what that means. Step 1, it means you add the parallel sides. So you do 10 plus 14 is 24, and the unit centimetres. Step 2, you half that number, so you do 24, you multiply by half or divide by 2, same thing, you get 12, and step 3, you multiply by the distance apart, which is 7.5. So you do 12 multiplied by 7.5, and you get yourself 90. Don't forget your unit. The lengths are all in centimetres, so the area will be in centimetres squared. So the answer here is 90 centimetres squared. Okay, I'm going to show you the next part of this question. Pause the video, have a go yourself, and in about 10 seconds I'll work through the answers. So have a look. Okay, let's have a look at this then. It says some of these trapeziums, actually the plural of that is trapezia, are put together to make a regular shape. Okay, the diagram is incomplete. How many exterior sides does this shape have? So we're creating a shape with these sides here. You must show your work in 3 marks. What I would do straight away is I'd move back to the question and remind yourself what the angles inside the trapezium were. This angle here was 75 and this one here was 105, right? So this one here must be 75, and this one here must be 105, etc. Because they're all the same shape, and the same thing applies all around. Okay, now exterior sides of a polygon. If I need to work that out, I'm going to use an easy rule, and it's to do with the exterior angles of a polygon. The exterior angles of a polygon, of any polygon, add to 360, add to 360 degrees. Now let me just show you what that means. Let's draw ourselves some sort of shape. Here's a shape here. That's a pentagon. The exterior angles mean that angle plus that angle plus that angle plus that angle plus that angle. Always add to 360. Doesn't matter if I've got a 5, 8, 11 sided shape. Doesn't matter if it's regular or non-regular. For any polygon, the exterior angles add to 360. So if I extended this line here, this angle here would be the exterior. Now these two add to 150, so this one must be 30 degrees because angles on a straight line add to 180. So if that's 30 degrees and all of these angles, that would be 30 for example, all of these, however many they are, add up to 360. If I do 360 degrees divided by each one, 30, it must tell me how many exterior angles I've got. So 360 divided by 30 is 12. That means I've got 12 exterior angles, and on any shape, for every exterior angle matches to a side. So that means that I've got 12 sides. Actually, it didn't even ask for that in this case. It just asked for how many exterior angles. So actually it does. It asks for how many exterior sides, how many sides the shape has. The answer is simply 12. Again, if you need to, you might like to write yourself a little revision card in case you didn't know that, on exterior angles of a polygon add to 360, and a little example here to show what an exterior angle is and what that actually means. Okay, next question involving a trapezium. Pause the video, have a go, see what you get. Okay, let's talk through this. It says that a company makes shapes from sheets of steel, and each shape is a semicircle and a trapezium as shown. So that side and that side are the parallel sides of the trapezium. So and the height, the perpendicular height, is 20 millimeters. Show that the total area of this shape is this to 3SF. Okay, clearly we're going to do that in two stages. We are going to work out the area of the semicircle and work out the area of the trapezium. Break it down, show the examiner what you're doing to get the easy marks. So area 1, I would write area 1 is a semicircle. Now, always when I'm dealing with circles, I label what I know. If this is a semicircle, okay, the diameter is equal to 30 millimeters, and the radius is half that. The radius must be half that, which is 15 millimeters. And I'm dealing with area here. I want area, so I'm going to use the formula pi r squared. So a whole circle, the area would be pi times 15 times 15. And you get yourself 706.85, so 706.85. So the area of a semicircle must be half that, must be half times 706.85, which is 353.4. So 353.4, and the unit millimeters squared. So I've got myself some good marks there. That's the semicircle. So step 2, the area of the trapezium. Again, you look in the front of your formula booklet, it tells you the area is a half a plus b times h, but you know what that means now. What that means is as follows. Step 1, you add up the parallel sides, so you do 30 plus 40 is 70 millimeters. Then you half that number, so you do 70 times a half, or divide by 2, is 35. And step 3, you multiply by the distance apart, which is 20. So you do 35 times 20 and you get 700, and the unit, everything was in millimeters, so it's in millimeters squared because it's an area. So total area then, I'm running out of space, you would have a bigger sheet of paper, so don't make it look as messy as I'm making it here, but total would be 700 plus 353.4, which adds up to 1053.4 millimeters squared, which if you round to 3SF, that would round to 1050 millimeters squared to 3 significant figures, and hence you've got your 5 marks there. Okay, using the information on this question, I'm going to show you the next part of the question. Pause the video again, have a go, see what you get, and then restart me up and I'll show you how to answer the next part. So pause the video here, have a look. Okay, let's have a look at this. Let's just remind ourselves from this part that the area of the total shape was 1050 millimeters squared to 3SF. Okay, it tells you that steel costs 0.05 pence per millimeter squared. Okay, so let's work out how much steel costs per shape. The steel cost per shape, well, in pence, it's 0.05. Remember the unit, this is pence, P times 1050, and you get 52.5 pence. But let's change that into pounds straight away to make everything easier. In pounds, that would therefore be 0.525 pounds. Okay, that's the steel cost per shape. You want to make 40,000 of these, so steel cost for 40,000, or 4,000 even, 4,000 would simply be 4,000 multiplied by 0.525, and you get 2,100. Okay, we've dealt with the steel. It also says that the shapes are coated with zinc to prevent corrosion, so it's 3p per shape. So let's call it zinc cost. Well, we've got 4,000 shapes, and each times 3p, which is 0.03 pounds, and the zinc costs would be 120. So you add these two together to get your total cost. Your total cost is £2,220. So the total cost of making this is £2,220. Okay, I'm going to show you the next trapezium question. As always, this is a new question coming up. Pause the video, have a go yourself, and then mark it based on my answer. So pause this here, have a go. Okay, let's take a look. It says here's a gold bar, and it has a trapezium cross-sectional area. So the cross-sectional area is like the face of the shape. Okay, so that's a trapezium. It says calculate the cross-sectional area of the gold bar. So all you've got to do is work out the area of this trapezium here. So really, what we've got ourselves a trapezium, 7 centimeters on top, 11 centimeters on bottom, and it's 5 centimeter perpendicular height. So the area is simple. Again, in your formula booklet, it says a half a plus b times h, and some of us might want to do it in steps. So we add up the 7 and the 11 and get 18. Then step 2, we half 18, so 18 divided by 2, and you get 9. And step 3, 9 times 5, which is 45. What's the unit? Well, everything was in centimetres, so it would be centimetres squared. So we would get 45 centimetres squared. Okay, next we've got something involving something called density. Gold has a density of 19.3 grams per centimetre cube. What is the mass? Give your answer in kilograms. It's 4 marks here. Right, now from science and from your maths lessons you should know a formula for density, but even if you don't, look at this. It's kind of given to you in a hidden way. Density, okay, they tell you it's 19.3 grams. The unit is grams per centimetre cube. Now per means divide, so the grams is mass, divide centimetres cubed is volume. Okay, so if you just look at the units, you get the density formula for free here. The density formula is mass divided by volume. So if you want to work out mass, therefore, mass must be density times volume. So mass is density multiplied by volume. Okay, now we know the density is 19.3 grams per centimetre cubed, so we do 19.3 times the volume. Well, the volume of a prism is the cross-sectional area times by the depth back. So it would be this 45 times 16. So the volume, that we might even do separate working, the volume is 45 times 16, which is 720 centimetres cubed. So you multiply this by 720 and you get 13896 and the unit grams. Now they asked us the answer in kilograms, so we have to divide by 1,000 and the answer in kilograms will be 13.896 kilograms. So to summarise this, you might need a new revision card here for what's the formula for density. Density is mass divided by volume. And also a little revision card in that revision card tell yourself how you could sometimes get it from the units if they're given. And also you might need a little revision card on the volume of a prism. It's the cross-sectional area times by the depth. Okay? Don't forget to always read the question and give your answers in the appropriate units. Okay, that's it for all the trapezium questions that came up in Unit 3 AQA Higher. Hopefully you found using the video tutorial useful and then following it through with these exam questions. If anything you have trouble with, take a look over it again, see if you can work it out and get those revision cards on the go so you're learning and remembering what you're doing at each stage, not just if there's some bit you didn't always get, just leaving it like that. A revision card should solidify in your mind. So thanks for listening. I hope you found it helpful.